their grass, their pasture species and so forth to deal with possible drier future conditions, another that doesn't, and this also translates to the wheat and whatever else is going on in each of those two farms. Here's a couple of very simple schematics that show the ways in which you can represent those different scenarios. So the story that's being told here is that the deeper rooted pastures survive better, stay green longer, the sheep look healthier, their heads are down eating, etc. There's subliminal messages here. And in the bottom image that's dried out, the sheep are skinny, they've got nothing to nibble on, and so forth. And that translates into the other kinds of land uses also. As the land suitability mapping has been built, you saw on the map there were specific outputs in terms of tonnes per hectare of barley or ryegrass or whatever. And so we also need to think about, well, can we represent that in a more intuitive way across the landscape and within the collaborative virtual environment. And this is one of the approaches that we've experimented with. Those little blue things you see on the right are little milk bottles, and we can change the density and the size of the milk bottles, and we can associate different parameters with those, so that we might associate, for example, size with total output and density with efficiency, or vice versa, other parameters in there. You also see the capacity to cut away the ground and foreground and see if we've got models linked into this about effect on groundwater, what's happening with the groundwater underneath. On the left, I think they're loaves of bread, but I'm not quite sure. Okay, so this was taken to a workshop in Portland, Victoria in August last year. There were all the usual suspects there, council members, planners, extension staff and us researchers. What we did there was people broke into 3 groups, each with a separate computer. The computers were linked to simulate people in different offices across Victoria or across the world, where they would have had the potential to collaborate in the virtual space. We didn't do a lot of collaboration on that occasion, but we took people for a guided tour through the virtual farm scenarios, let them see how the different avatars of the different kinds of people who were in the space could collaborate and so forth. And the feedback was fairly good. It wasn't a detailed study. We did get some questionnaires filled in, and generally there was a feeling that yes, this is a promising technology, and there's a place to go with this. However, we would like to see more realism. The current stuff we were showing was perhaps on the cartoony side. But even more important perhaps is the need to ensure that the scientific research that underpins it is indeed accurate. And that we need to think also about uncertainty in contexts like this and how we represent that, and whether the images, particularly if we make them even more realistic, are potentially communicating something that's looks certain but is uncertain. Here's a couple of avatars that have recently emerged from the lab. So let me move to conclusions. These are a couple of conclusions about the modelling side of things, which is not my expertise. But the challenge that Victor and the group at DPI have identified is that we really want to do this across the range of climate change models, because there's uncertainty from that very first level. As you know, all the IPCC models range across a wide range of outcomes. And so in order to understand the uncertainty at the suitability level, and therefore the uncertainty in the visualisation, we need to cascade all of that through down the whole chain. On the visualisation side of things, it was immediately apparent that we needed better exchange capabilities. The climate modelers, for example, those who are doing the regionalisation, didn't know anything about GIS formats and therefore had to be told to prepare new output routines that would output their data in GIS ASCII format that could be easily read. So in the long run, we hope that all of that might be automated, but at this stage, there was even a stage of quite protracted discussion about how best way to communicate those things. Generating the visualizations from the suitability model is pretty simple procedurally. The difficulty was that there wasn't the sort of object library already in existence that Falak has mentioned. There's the start of it, and it's growing as we speak. But until you've got a very wide range of tree species and buildings and animals and so forth, and those tree species are not only in their mature state, but also in the various immature states, perhaps also in different states of disease, perhaps also having survived or not survived the bushfire, etc. So essentially we want to visualise the landscapes after emergency situations, after climate change, etc. And so that object library can grow exponentially. You've already seen the fat sheet and the skinny sheet. We also produced, or actually mainly produced at DPI, biofuel plants, use of photovoltaic panels on barns, alternative technologies that help with the whole procedure. And finally, the point I've already made, and it's just reinforcing what has been said before, that without a comprehensive and accessible object library, there's always going to be a bottleneck in this visualisation process. So, thank you. Oh, just to say that to indicate that not only what Falak has said is true, but we were also working with our Department of Sustainability and Environment in Victoria, and so there's a whole team of people ready for the Spatial Sciences Congress in Adelaide that will focus even more closely on this issue. Thank you.
We've got time for some questions for Ian.